Hi, welcome to the 90 Days of DevOps, saving cloud costs using existing Prometheus metrics talk. We'll start talking about the problem, which is cloud costs and how it's also affecting Kubernetes, CPU, memory requests and limits, and how they are useful, what KRR is, a demo of KRR, and some common questions that we get asked when we talk about KRR, and also some key takeaways. Over the past year or two, you might have seen a lot of companies sharing that they are either completely moving to on-premise or partially going hybrid to save on cloud costs. And you might have wondered, so if the cloud era is gone, or if you should also move back to going on-premise. But we know that there is a reason why people moved from on-premise installations and to the cloud, and that is to save costs and also save on maintenance, save on infrastructure. And when you are a fast-growing company, it's really hard for you to scale if you have all the infrastructure on-premise. This is a study from SysDig, which was released last year, about Kubernetes over-allocation and how it's affecting your costs. According to this study, over 69% of your costs can be saved because if you allocate resources correctly when using Kubernetes. Before we jump in, a little about myself. I'm Pawan from Robusta. I work as a developer advocate there. I'm also an open source lover. I write blogs and make videos mostly about anything Prometheus. Now, going back to our problem about Kubernetes over-allocation and how it's burning cache for us. So how do we save costs, and how do we save costs on Kubernetes? The answer is not complicated, it's pretty simple, as you might have already guessed, and that is to allocate resources better. It's that simple. You just have to make sure all the applications get the right amount and not too much, so that you'll save on cloud costs. But how do we do that? If you have worked with Kubernetes for some time, you might have already seen the Kubernetes resource requests and limits. You might have even tried to tweak them and get them to working. This is a common problem we had a lot of users and customers ask at Robusta. We already use Prometheus metrics, and they were getting alerts about their nodes being insufficient, pods not being scheduled, and that sort of things. And we wanted to do something to not just predict these values and use the existing data from Prometheus and try to give a data-driven recommendations for these values. So that's why we made KRR. KRR is an open source CLI tool that works with all Prometheus compatible systems, and just run it once and it'll give you recommendations. So in simple, this is how KRR works. When you run KRR CLI, it connects to your Prometheus, and it analyzes your Prometheus history and gives you some CPU and memory requests and limits. The main features are that you don't need any agent running on your cluster. You don't need anything running continuously on your cluster, and it is Prometheus integrated. So all the recommendations that you get are based on the data of your own applications being run on your own environments. This is not some guesswork. Say, for example, this is a Python application and this might need X amount of resources. It's extensible because KRR is open source. You can tweak it, add your own algorithms, extend it, and modify it to work for your own specific needs. Let's take a look at how KRR works and what it does for you. Go to the Robusta KRR repository, and here you'll find the requirements for you before you install KRR. If you have Prometheus and kubestate metrics, that should be fine. These are the metrics that KRR uses. If you installed Prometheus using kubeprometheus tag, then there's no configuration or anything extra that you need. If you are using Linux or Mac and you have Brew, you can install KRR directly. If you are on Windows, you need WSL. In this case, we'll be cloning the repository and trying out KRR manually. You can also find how these metrics are gathered and how they work in the How KRR Works section on the README. I cloned the KRR repository locally and installed all the dependencies using a Python virtual environment. Now we'll run KRR on this cluster. This will take some time, and KRR looks at the past 14-day history of all of your applications and processes it using, here in this case, the simple algorithm to give you some recommendations. The -- quite flag only gives you the recommendations and not show you how the process is set up. Here we see how the algorithm works and some other details about it. And these are the recommendations that you get. We have all the namespaces and the name of the Kubernetes object and the Kubernetes object type here. The pods are the currently running pods, and any old pods is the number of pods that were previously active. Here we see the container name. So KRR gives you recommendations for each of the containers. So if you have multiple containers inside a pod, you will see separate recommendations for each one of them. Here we have CPU requests, CPU limits, memory requests, and memory limits. The CPU difference and memory difference columns show you the change in the value that KRR is suggesting. Here in this case, based on the application's usage, it's suggesting to add plus 251 M of CPU. However, in this case, it is suggesting to remove memory. Here in this case, 925 MI, or here 412 MI. You'll have all the recommendations given for you like this, depending on how many applications you have running on the cluster. Now that we saw KRR in action, let's address some of the common questions that we get. Why no CPU limits? If you haven't noticed already, all the recommendations will show you either to unset your CPU limits or to just not have them at all. This is because of how CPU limits in Kubernetes works. We have a detailed blog, and also our co-founder and CEO Nathan gave a talk about CPU requests and limits at CO Navigate. Feel free to take a look at them for an in-depth analysis of why you should or shouldn't use CPU requests and limits. KRR was VPA. VPA is Kubernetes vertical pod autoscaler. The key differences is that VPA runs in your cluster. VPA has to run in your cluster all the time, and you also need some time before VPA starts giving you some results, while KRR runs instantly and gives you results based on your existing history. Also, VPA tweaks the application directly, while KRR only gives you the recommendations, and you get to decide if you want this to be applied to your cluster or if you don't want it to be applied. KRR also lets you add new strategies, new algorithms, so you can also get better results that are catered to your own applications. And another question we get is, can I do more with KRR? I want it to work with work as more than just a CLI. I need to see more data about it. I need to see why it's recommending and that sort of things. Yes, you can. Using the Robusta open source, you can configure it to run occasional KRR scans and send you the reports on your Slack or any of the 15 plus integrations that it has. If you are using the Robusta SaaS, you get a detailed explanation of all the recommendations, your previous usage history, and why KRR is recommending you these values specifically, and also a config to change this. KRR also has a K9S plugin. You can install this K9S plugin and get recommendations directly. That brings us to the key takeaways of this talk. Requests and limits can save you a lot of cloud costs, and to predict them, you don't need new data. You can use the existing Prometheus data. If you have any Prometheus compatible data source, that also works. You don't need to provision more resources. You can utilize the existing resources and get better results. You can also automate the process of KRR sending these results. Thank you for listening. Here's KRR GitHub. Feel free to try out KRR. Send us your feedback. Give the project a star if you like it. If you have more questions or if you want to talk about anything Prometheus or KRR or Robusta, feel free to reach out on my socials. Have a great time.